Okay, so before we look at an ellipse and a hyperbola defined in terms of the focus and directrix, I'd like us to be reminded of a parabola. And this is back to FP1. And I want you to spend a few minutes to tell me, in order to satisfy that given condition, that the distance between the point known as the focus to any point on the curve, in other words, this is the locus of points that satisfies this condition, that any point P on the curve must be the same distance to the focus as it is to this line called the directrix. Okay, if P satisfies that condition, what is the Cartesian equation for all points P satisfying that condition? And excuse me. Okay, so in order to satisfy that condition, we can say this is the point X, and this distance given in terms of X, A and Y, this distance, the green distance, the hypotenuse of the triangle, we can work out to be X minus A. In other words, this little distance here is X minus A squared plus that distance there, which is Y squared. Okay, so that gives us this hypotenuse here. And that has to equal to, let me shrink, this distance here. Well, from here to here is A, and from here to here is X. So that distance has to equal to X plus A. And therefore, that distance squared is simply X plus A squared, because we, on the left-hand side, we don't actually have the hypotenuse. We haven't square rooted it. We've got the square of the hypotenuse. Okay. Simplifying this, multiplying out the brackets, and simplifying, we have the equation y squared equals to 4ax. And I can leave you guys to fill in the details. One.